I have a question for people who, you know, believe in Einstein's special theory of relativity about the length contraction and mass contraction and all that. So specifically, just a problem with the length contraction, and actually also something about the time travel and all that. Okay, so two doubts I have pertaining to these two things about the special theory of relativity. Um, okay, so you know that according to that theory, what happens is whenever someone travels closer to the speed of light, there is a reduction in the length of that particular object in the direction in which they are traveling, right? So this is the exact thing, exact theory. It says, when an object travels, it reduces its length reduces in the direction in which it's traveling, and it's given by the formula which is similar to the Doppler effect formula and all that. So something happens, let's say an object travels at a speed of like 90% of the speed of light or something. Its length contracts maybe around 50% or something. Let's just assume that according to the formula given, right? So I have a question with this. So imagine a car and a garage, okay? So that this is the garage, like with the three walls, and then this is the car. So the car could exactly fit in the garage. Okay, so now what you do is you just open the back doors and then you sort of keep them fixed, so that when the doors are open, only half of the car can enter through the garage, because the doors would stop the car from entering the garage. Okay, so garage and a car of equal length, but now you have the back doors open, so that only half the car could fit in the garage. Okay, so you take both of them onto outer space, right? And then now you make them move, either one, either the garage or the car. So you have a driver sitting in the car, and then you have another guy who's standing in the garage against the back wall of the garage, and he's just standing there. So so the the garage and the car are approaching each other, and now the guy who's sitting in the car, he's gonna think that the garage is moving towards him at a speed of 90% the speed of light. So he would assume that the garage would reduce about 50% in length. So he would think that he should be able to bump in to the guy standing against the back wall of the garage. Okay, so that is what this guy sitting in the car is thinking. Whereas the guy who's standing against the garage wall, he sees the car moving towards him at a speed of 90% the speed of light, and according to his calculations, the length of the car has to reduce in that particular direction. So he would think that the length of the car is going to further shrink by 50%, and since the back door is already open, so the car can't enter the garage. That's what he would be thinking, right? So who's gonna you know what's gonna happen? Is the car gonna hit the other guy, or is the car gonna get stopped? So right there's an anomaly. At least one of the guys, either for the guy sitting in the car or either for the guy sitting in the garage, something, this anomaly is going to happen, because the guy in the car, according to the calculations, like one thinks that the thing has to bump to its end, while the other one doesn't think so. um okay, so think about this. What is the what Einstein has said, that length is going to contract, so what's going to happen here? So that's the question, right? And then you can also extend the same scenario. People might try to come up with all these weird explanations, like because the car is decelerating, the other one is accelerating, and then these things are gonna um what there's going to be change in length, and what's going to happen is both would happen. Yeah, some people would say that when the car back doors gets bumped into the side walls, what will happen is the car decelerates, whereas the garage starts accelerating. But there's no condition here that the garage should start accelerating. Let's just say, um, well, let's just say it's a really strong garage. Okay, it's backed up by a mountain or something, so it's not gonna move. Okay, let's just assume that. Okay, So anyway, the people say that the car decelerates and the garage also doesn't accelerate, okay, because it's that big of a garage. Okay, so in that scenario, as long as the car is decelerating, right, it is having a velocity. So as long as it has a velocity, the length of the car would contract. And like I said, in the same inertial frame of reference, when they both bump, the garage is not going to move away. The car is just going to hit and bang, stop. The garage is not moving away, or they're not moving backwards or whatever. The car hits and stops, right? So in this scenario, there is no acceleration acquired by this garage. So the length of the garage won't reduce. And this guy sitting in the car is thinking, what happened, because the garage came and bumped onto me, but we're both stuck here. um, According to Einstein, the length of the garage should have reduced, so I should have, bumped against the back door, sorry, the back wall, and killed the guy standing over there. But that didn't happen, right? So that's an anomaly, right? And you can actually extend this. We can sort of, okay, just for the sake of the guys who would say that both the things happen. They Some guys would say that both the wings would I mean the back door would press against the side walls and the car would stop. But then like in a cartoon or something, the car is going to expand and the garage is going to shrink, and then both the front impact and the side impact is going to happen. That's what some people would say. So for that people, I would say that let's assume that this is a garage, okay, and the garage is a piezoelectric material. So what happens is, when you first have an impact in the side walls and then the impact in the back wall, let's say this whole device is connected to a, a, a circuit, and it's connected to a red or green light, right? So let's just say that if the garage wall, the back wall has the impact first, and um, the side walls have the impact next, it's going to have red light. Whereas if the side walls have the impact first and the back wall has the impact next, it's going to be a green light, right? So in that scenario, only one thing will happen: either the red or the green light will happen, right? So there again, there's going to be another anomaly for either one of the guys, like either the one who's sitting inside the car, or the ones who's standing by the back of the garage wall. So they're going to be seeing anomalies, right? And so how does this special theory of relativity explain this anomaly, the car and the garage anomaly, right? I mean, if you haven't really understood what I've spoken, I think you should just rerun the video and then draw down the scenarios or whatever. I think I've made myself reasonably clear. So yeah, you can just run the video again and imagine what I'm trying to talk about, right? So that's one scenario. And so if you're gonna say that, okay, we're gonna see anomalies here all the time, if you're gonna see green lights and red lights all the time, none of the semiconductor devices are gonna work. None of the electronic devices are gonna work, because it's all based on movements of electrons, right? And then electrons do have definite mass, and I know it doesn't have a particular length or anything, but there's going to be a lot of anomalies, like the matter that composes all these, I mean the fundamental particle that composes all these all the things that we see here. There's going to be a lot of anomalies when it comes to electronics and computers and all that. So but we haven't seen any because like electrons coming from the opposite side is just gonna end up with the same scenario, right? It's gonna get confused which is gonna reach to point A first, this one or that one. There's gonna be so many confusions when you try to think about the various inertial reference frames that could happen within a semiconductor chip and all that. um, so but we don't see any electronic anomalies, right? So how does one explain the length contraction, the anomaly um, that arises with this length contraction thing? And then they think, okay, so what is the proposed scenario they ask? I would just say, light gains and loses speed depending on what is emitting it. For example, if a photon is emitting light, which is already in movement. Sorry, no, what am I saying? An electron is emitting light, which is already in a movement, or let's just say any light source, laser source, right? if the laser is sort of moving at 50% of the speed of the light, and it emits light, the speed of that particular photon in a particular reference scale is going to be 1.5 times the light which is being emitted from a static source in that particular reference frame. And so if someone is emitting light from the opposite direction, um, you know well, they talk about this Michelson-Morley experiment, right? So it says, okay, the light took the same amount of time to reach between point A to point B, and even the reflection, they say, took the same time to reach back, right? So I would say that the reflected light, the velocity of that light is sort of reduced to a small extent based on the movement of the Earth, right? So that is what I would say. People think that all these white guys, they're really smart, right? The Michelson, the guy who did this experiment, and whose observations finally made us conclude that the speed of light is constant, that guy couldn't even figure out the distance traveled by the light between the two mirrors, exactly. I mean, even a 10th standard math student would have done that, but that guy made a mistake. If you just manage to read about the Michelson-Morley experiment and what the error this guy did, it was pretty simple. He simply assumed the distance is 2x or some bullshit like that, but he didn't even think about there's going to be a change in distance and all that. So those guys are not really that smart. And so whatever those guys theorized in 1880 or whatever, I don't think you know we should just take it as the I mean, we should sort of re-examine that as well. So yeah, light, I don't think it's just like someone is throwing a ball from a train. The ball is going to be uh, it's going to come at you really fast compared to a guy who's just standing throwing the ball from a stationary platform or whatever, right? Because the ball has extra velocity from the train as well. So I think that the same thing happens with light as well. The speed of the light increases and decreases as well, depending on what who's depending on the light source, and that, right? So that is my thing, right? um so that is number one. And then the second scenario is about um the time travel and all that shit. I think people think, oh, you can also travel backwards. And what the hell is backwards in time? Is it all gonna be like a rewinder thing? If you travel backward in time, my hands are gonna go back. And what is this, huh? What exactly does going back in time mean? Like, um, at time t, I have my hand in my head or whatever. Time t plus 2, I'm sitting normally. So for me to go, if we going back to time t, am I still going to have my hand in my head, or what is exactly do they mean by going back in time? If I'm going to go back in time, and I'm not going to be doing that, I mean, what exactly are the physical world implications of going back in time? It's just bullshit, time travel concept, according to me, I'm saying. So I mean, there's also another scenario, right? So let's just say time travel is possible, and then you travel back in time, and then you give a watch to your grandmother, right? And let's say you're like 20 years old now, and then you give this watch to your grandmother, and then that but what the how you got that watch is that your grandma gave it to you when you were 5 years old, okay? And you've time traveled about 30 years back and given the same thing to your grandmother, right? So if you ask you from where you got the watch, you're gonna say your grandmom gave it to you. But if you go and ask your grandmom where she got the watch from, she's gonna say you gave it to him. So who exactly manufactured the watch? Where did the watch come from, right? I mean, I don't know. There's so many people studying physics. They've all learned all this, right? Like every single country, every single school in 10th grade or whatever, they taught relativity, right? Why the fuck doesn't anyone ask these questions? Well, I asked, and teacher didn't say anything. But let's just say, so if these two scenarios, someone in YouTube can answer this, right? And we can sort of discuss further in the comments. All right, bye.